Hello, Math 3 students. So today we are going to be talking about horizontal asymptotes of irrational functions and finding the y-intercepts and x-intercepts. So first off, to find the horizontal asymptotes, there's kind of three situations that could be happening. Basically, what you have to do is you have to look at the degree of the numerator and the degree of the denominator, okay? So the first one is if the degree of the denominator is bigger than the degree of the numerator. So for example, let's say we had like x plus 2 all over x plus 1 times x minus 3, okay? On top here, we have a degree 1. On bottom, we have a degree 2, right? Because if we multiply this out, we end up with an x squared here in the denominator. So in this case, our denominator is bigger than our numerator, okay? When that happens, okay, that means that our horizontal asymptote is going to be y equals 0, okay? And the reason for that is essentially because the bottom grows faster than the top. As x gets bigger and bigger, the function will eventually approach 0. Won't reach 0, but it will approach 0. The next case we have is if the degree of the numerator and the denominator are equal. So let's say we had 2x plus 1 times x plus 5 all over 3x plus 6 times x plus 3, okay? This one we have a degree, we have a degree 2 on top, and on the bottom we have a degree 2 on the bottom. So in this case, the degree of the numerator equals the degree of the denominator. When that is the case, what you need to do is you need to get it into standard form, and you look at the leading coefficients, okay? So we're going to go ahead, if we can FOIL this out, we get we get 2x squared plus 10x plus 1x, which would be plus 11x, plus 5 on top, and then on the bottom, we would get 3x squared, and then we get 9 and 6, which would be 15x, plus 18. So I just multiplied those out. As you can see, obviously, we have same degree on top and the bottom. So what you do at this point is you look at the leading coefficients, okay? So the coefficients on the highest powers, that's what your asymptote is going to be. So in this case, our asymptote would be y equals 2 over 3. All right, that would be our horizontal asymptote. Now, if the numerator is bigger than the denominator, okay, so for example, let's say we had 3x plus 1, x plus 5, all over 2x plus 5, okay? This one, we have a degree 2 on the top, a degree 1 on the bottom. That means that our numerator is going to grow faster than our denominator. That means that there's no horizontal asymptote. We actually have what's called a slant asymptote, all right? But we have no horizontal asymptote, all right, if the degree on top is bigger than the degree on the bottom. All right, so they want us to find the horizontal asymptote here. So first we have to figure out what case we have, all right? So if we were to go ahead and multiply this out, we get x squared plus 14x plus 40 on the top. And on the bottom, we would get x squared plus 6x plus 8 on the bottom. So our degree of our numerator is equal to the degree of our denominator. Now, when the degree of the numerator is equal to the degree of the denominator, we can go back up here and look. Well, what we do is we look at the leading coefficients of the numerator and the denominator. Well, my leading coefficient on top is 1. My leading coefficient on the bottom is 1. 1 over 1 is 1. So that means that my horizontal asymptote is going to be y equals 1. All right, let's go ahead and try this one. So this one is actually already in standard form. Determining the leading coefficients is easiest to do when it's in standard form, so we don't have to even FOIL these out at all. If we look, my degree on top is 2. My degree on the bottom is 2. All right, so that means that the degree of the numerator equals the degree of the denominator. Again, when the top equals the bottom, we look at the leading coefficients. So we've got a 2 and we've got a 1. that means that our horizontal asymptote is going to be y equals 2, because we do 2 divided by 1. All right, let's try this next one. So if we look, the numerator is ready to go. However, the denominator, we got to multiply out. So we get x squared, and then minus 9 minus 8 is going to give us minus 17x plus 72. Now, x minus 8. So we could go ahead and distribute that 3. We get x minus 8 all over, and then we get 3x squared. Negative 17 times 3, negative 51x. And then 72 times 3, we get, 216. So all I did there was put the denominator in standard form, multiplied out, distributed my 3. So if we look at it now in standard form, the degree of our numerator is 1, but the degree of our denominator is 2. Okay, so that means that the bottom is bigger than the top. So if we look back here, if our bottom is bigger than our top, which is what it's showing here, that means that our horizontal asymptote is going to be just y equals 0. And that's our answer. All right, let's go ahead and try this one out. So this one, I would say you probably don't even have to multiply out to do. Our degree on the top is going to be 2, and our degree on the bottom is going to be 1. You could go ahead and put this in standard form and see that the highest power on top is x squared, the highest power on the bottom is just x. And in this case, our numerator is bigger than our denominator. So if we look, when our numerator is bigger than our denominator, there is no horizontal asymptote. This will have what's called a slant asymptote, and we'll talk about that later. All right, let's try this one out. So looking at this one, neither of these are in standard form. So what we could do is get these in standard form here. We get 15x squared plus 12x. Then on the bottom, we get 5x squared, and then what, 10 minus 3, which is going to be plus 7x minus 1. All right, so then we got to look at our degrees. The degree of our numerator is 2. The degree of our denominator is 2. So when they're equal, that's when we look at the leading coefficients, okay? We've got 15 over 5. That means we're going to get y equals 3. All right, let's try the next one. So if we look on top here, that one's good to go. We can distribute the 3 on the bottom. We get 6x minus 21. So my degree on top is 1. My degree on the bottom is 1. So that means when they're equal, we look at the leading coefficients. That means that I get 5 over 6. We can't simplify that. So my horizontal asymptote is going to be 5/6. All right. Next one. All right. So we could go ahead and distribute here. We get 2x squared plus 2x. And then on the bottom, we would get x squared minus 49. We can distribute that 3, 2x squared plus 2x, 3x squared, and then I don't know what 49 times 3 is. It is 147. Would never have guessed that. So minus 147. All right. So then, again, my degree on top is 2. My degree on the bottom is 2. They are equal. Again, we're looking at the highest power to determine the degree. So if we take our leading coefficients, we get 2/3. So y equals 2/3. All right. Now this one's already in standard form. And just to kind of reiterate, factored form is when it looks like this, right? When you have the parentheses. Standard form is when it's all multiplied out. So in this case, we've got a degree 1 on top and we've got a degree 2 on the bottom. So the bottom is bigger than the top. That means that our horizontal asymptote is y equals 0. All right. Next thing we're going to talk about is x-intercepts. All right. So x-intercepts occur when the numerator is equal to 0. All right. So basically what you want to do is you want to take the numerator, set it equal to 0. However, one thing you have to check for is you have to kind of double check that that's not a whole. So first you check to see if you have any holes, then you set the numerator equal to 0. So again, this is just going to be a ton of factoring. So first thing we need to do is factor the top here. So we get x, let's see, negative 8. So how about plus 4 minus 2? On the bottom here, we're just going to have a GCF of 3x. So we get x plus 4. All right. So looking here, these guys cancel out. When something is a whole, it can't be anything else. All right. So like when something's a whole, it can't be a vertical asymptote. When something's a whole, it cannot be an intercept. It's a whole. Point doesn't exist. So we know we have a whole at x equals negative 4 here. All right. So again, to find the x-intercepts, you just set the numerator is the top. You just set it equal to 0 after checking for holes. So I would just do x minus 2 equals 0. I get x equals 2. That is my that's my only x-intercept here. All right. All right, let's try this next one. So on top, I can take a 2 out. I get x plus 9. This one, unfortunately, it looks like I'm going to have to do some AC factoring here. So I'm going to do 2 times 27, and I get 54. So we need to multiply to negative 54. I'm going to actually just do this up here. And we need to add to 15. Let's see. That's kind of a tricky one. What about 18? Let's see. Yes, that does work. So it looks like to multiply to negative 54, we could do 18 and negative 3, and then those are going to add to 15. So we're going to go ahead and do our AC factoring, which is 2x squared plus 18x, minus 3x minus 27. All right. So we can go ahead and take out our GCF here, which is going to be 2x. We get x plus 9. Now, looking at taking the GCF out here, we know we're trying to get an x plus 9. So let's try and factor out a negative 3, right? And we get x plus 9 there. So this factored is going to be 2x minus 3 and x plus 9. All right. Now, looking here, we've got a whole at x equals negative 9, okay? Because we have a whole at x equals negative 9, that x plus 9 cannot represent a y-intercept. So all we're left with on top is a 2, right? So you're supposed to set the numerator equal to 0. You can't make a 2 equal to 0. So this actually has no x-intercepts. All right? Let's try the next one. All right, so in the numerator here, we cannot factor anything, so we just get 2x minus 9. Here, we're going to end up with x plus 10, x plus 1. So nothing cancels, all right? So we're just going to set our top equal to 0. We add 9. Divided by 2. We get that x equals 9 over 2. Or 4.5. So our x-intercept here is going to be 9/2. All right, let's try the next one. All right, so unfortunately, it looks like we got some AC factoring up here, so let's practice that. Oh, I don't want that. I want my calculator. All right, so 5 times 40 is going to be 200, right? So we need to figure out what multiplies to 200, and then we need to add to 54. Let's see, probably 50 and 4, right? Yeah, so we're going to do 50 times 4. So let's go ahead and write this out. We're going to do 5x squared plus 50x plus 4x plus 40. We can take a 5x out. We get x plus 10. Here we can take a 4 out, x plus 10. So our numerator factored is going to be 5x plus 4 times x plus 10. And then on the bottom, we can take a 2 out, so we get x plus 8. All right? So in this case, again, nothing cancels. So we have to set everything in the numerator because nothing went away. So we set everything in the numerator equal to 0. So we're going to do 5x plus 4 equals 0. X plus 10 equals 0. All right? So we do minus 4 minus 4. 5x equals negative 4. X equals negative 4/5. That's one of our x-intercepts. And then in this case, we get x equals negative 10. That's our other x-intercept. So you could have multiple x-intercepts. That was the first one that had multiple. You could have none, you could have 1, you could have 2, 3, 4. It could keep going up. All right. All right. So last one here, this one's quite easy. And we've done this before. To find a y-intercept, okay, you just plug in 0 for x. That's literally all you do. So we're going to go plug in 0 for x here. We get 0 minus 7 times 0 minus 18 all over 2 times 0 plus 4. We end up with negative 18 all over 4, which will simplify to negative 9/2. So that would be our y-intercept. You could write it as a point. You could do like 0 comma negative 9 over 2, or if there's, depending on what they're asking for, you could provide either answer. All right, same thing here. Plug in 0 for x. 2 times 0 plus 16 all over 3 times 0, minus 10. We end up with 16 all over negative 10, which we can divide both by 2, so we get 8 over negative 5. So negative 8/5 would be our y-intercept here. Next one, again, just plug in 0 for x. Actually, this one's an interesting one. If we do 0 for x here, we actually end up with negative 90 over 0, which means that it's undefined. And if you had worked through this problem previously, you actually would have found that there's a vertical asymptote at x equals 0. So this one has no y-intercept. Because obviously if you plug that in, you're going to get undefined. So if you end up with divided by 0, no y-intercept. All right, again, we plug in 0 for x. So we end up with negative 64 all over negative 32, which we can divide both of those by 8, right? The negatives go away. We get 8 over 4. Oh, I guess, wow, that's literally just 2. LOL. All right. So again, to kind of reiterate, horizontal asymptote, you have to compare the degrees, okay? For x-intercept, you need to factor completely, find any holes to exclude them, then set the numerator equal to 0. Then to find y-intercepts, you just plug in 0 for x.